But Rex, I don't know if you agree with me, but this work is rather easy. Okay, but I want to add that this work is only easy if you actually do your work. Right, so let's quickly have a look. I just want to go through a few notes with you that we need to make sure of. Right, I'm not going to go through all the grade 11 work because we don't need to know all of that at this point. I just want to, what I'm really worried about is the motors and the generators. Right, let's just quickly go through this. An electric motor, very important, electric motor converts electrical energy into kinetic energy or into mechanical energy. Right. And yeah, they give us a whole lot of stuff, but what is important here is to know a simple DC electric motor. You will also see they use another word here, a commutator. Right, okay. A commutator or a split ring. Okay. Most of our books make use of split rings because that is the main difference. Right? We also then have contacts, right? I just quickly want to mention here, they say to us, we have a commutator or a split ring, which you can see in the diagram below. The commutator turns the coil and regularly reverses the current through the coil. This ensures that the coil keeps turning in the same direction. Right. So that is a nice definition to know what a slip ring is. Right. What it does is it regularly reverses the current through the coil to ensure that the coil keeps moving in the same direction. Right. And then the other thing we spoke about is the contacts. We mainly speak about the brushes. Where do we find them? They're these little thingy-majiggies. Right? They are on either side of the commutator, and what do? They keep the commutator or the split rings attached to the battery by means of the brushes. Right. So in other words, they complete the circuit in short. Right. Okay? Right. So that is a DC motor. Right? They say a DC motor, the turning motion of electric motors does valuable work. And then they say we must look at both DC and AC. Right, okay. So that was the one thing I wanted to mention to you. Then the next thing that is quite important over here is the generator. And can you see what the difference between a generator and a motor is? If you were doubting this, look there. A motor took electrical energy to kinetic energy, while a generator converts kinetic energy to electric energy. Let's just go back. Can you see this motor that I had here? Had a little picture there. It had a power source, you see? And that is why it was a DC motor, right? Okay. Can you see? Yeah, we have no power source. So that is why it is a generator. Right. And now what happens in this generator? Mechanical energy is going to turn this coil, right? In the form of steam, someone cycling, whatever, right? So this is, the mechanical energy is going to turn in this coil. What is important here is that we can immediately identify that this is an AC motor, a generator. And why is it an AC generator? Very important, because it has slip rings. Right. Energy is required to turn the coil in the magnetic field. And then the brushes push past the slip rings, and they also make sure that it's completed. And then, very important, here we are going to use Fleming's right-hand rule. Right. And once again, this is what the AC generator looks like. And remember, we discussed it as well. They say, yeah, we've discussed this. I just want to read it for you. When the coil reaches vertical position, the coil can't move up or down anymore, and the current momentarily stops, right, at 180 degrees. And what happens at this point, people? Momentum will actually push it over, and it will actually continue to move. Right. Very important. We've discussed this. How can we increase the current generated? We want to increase the current. So we can't increase the current by increasing the current. Remember that. Right, so the one thing we can do is we can increase the number of turns in the coil. Right, we can make coils of a larger area. We can increase the magnetic field. And remember, what did I say to you? We can use a horseshoe magnet, eh? And then we can cause the coils to turn faster. Right. I wonder if you can remember what we do over here. Can you remember what we do over here? Right, what we do over here, ladies and gentlemen, we can increase the current. Why can we increase the current? Because we have a power source. We can increase the number of coils as well. And we can increase the magnetic strength. Okay. Right, so that we have got there as well. Right. DC generators, remember we've just discussed this was an AC generator. Remember the difference between a GC generator. A DC generator looks a lot like the DC motor. It also has split rings. Right, okay. Then the next thing that we had to know was alternating current, and we need to know that our alternating current graph looks like this. Yeah, we can see when a coil's there it's 0. And then remember what happens? It will be pushed over by momentum. Right. And you need to remember that we will not always be getting maximum. We make use of the RMS there. Right, so that is what my current, my AC current graph would look like. And then in South Africa, I want to mention this because they do often ask you about this, so you need to know about it. Alternating current in South Africa works on a frequency of 50 cycles per second, right, 50 hertz. And that is, so in other words, what is happening is it is changing direction 50 times in 1 second. Right, okay. And then I explained to you about the root mean square. The root mean square is going to be what we're going to refer to our average. And remember that if you needed to work out how much DC current you would need, then you would have to work out the RMS. Right, okay? So you need to remember that as well. And there we have our calculations. Right. Okay, now